Okay, welcome to this debrief session on the supply chain simulation. And this is the debrief for scenario 1, which is called Conquering the Market in Calopea. As you can see in the map, you work in this fictional world where there are 5 regions. In scenario 1, you're trying to sell your products in one province called Calopea. And in scenario 2, you're allowed to expand to other provinces as well. So you've done scenario 1, and the goal of this video is to explain how scenario 1 works, what you were expected to learn, so that when you go to scenario 2, all teams are at the same footing and all teams have learned the important lessons from scenario 1. So that's the purpose, okay? Okay, so, hopefully you read this write-up on scenario 1, which explains everything in detail. And you'll have a similar write-up for scenario 2 as well. So please read those in detail, okay? You can see that our supply chain has 2 stages. So we have a factory that ships products to a warehouse, and the warehouse ships products to the end customer. Okay. If you click on, so this is the simulation for the do nothing team for scenario 1, which ended their run with $6 million in cash. So if you look at the warehouse, this is where you can choose whether you want the shipment method to be truck or mail. You can set the order point and the order quantity. You don't have multiple warehouses. If you did, then in scenario 2, you could set their priority. So if 2 warehouses ordered from the factory at the same time, which gets priority. And then at the factory, you can adjust your capacity. And then you can set the shipping and the order quantity parameters for this particular warehouse as well. If you have multiple warehouses, you'll have multiple rows in this table. Right? So you can, the warehouse settings can also be set at the factory. And then at the headquarters, you can plot the demand and examine the demand. Okay. So you have to decide how this shipment is going to happen, right? Truck or mail. You have to decide how much to order. What is the queue that you order? That will then be shipped along this route. You have to decide when to order. Right, and when to order is decided by the reorder point. I'm going to call it ROP. In your simulation, if you look here, is called the order point, right? It's basically the reorder point in inventory management. It's called order point, right? So ROP or order point, because when your inventory at the warehouse hits the reorder point, you place the order. There's no inventory at the factory other than work in process. So when the factory gets an order, it produces the order, right? And while it's producing the order, there's work in process inventory. But when it's done, it ships out the order. It does not keep finished goods inventory, right? So there's no finished goods FG inventory here. The warehouse does keep finished goods inventory. So any demand that comes is fulfilled from the warehouse. So all demand, right? All demand is fulfilled from the warehouse. This is important to note because let's say you set a massive order to be produced by the factory. So you said, okay, make me 1,000 pieces or something, right? And you're in the middle of making that order. So maybe you have 5,000 pieces already produced sitting here and you're in the middle of producing this order and your inventory runs to 0 here. You can't just read out demand to be shipped from the factory. You will have lost sales because you're out of product at the warehouse. Factory does not ship to end customers. Customers can't order directly from the factory. Factory has to replenish the warehouse, and then the warehouse can ship to the end customer. Yes. All of these details are provided in the write-up. So before I go forward, what I'm going to do, I have a lot of facts in gray, in blue color in the write-up to attract your attention, but specifically the numbers about cost of something, things like that. I want to put them in an Excel file because we will need them for our analysis. Okay. Now, in terms of timeline, you get control of the factory at the end of year 2. Right? So there's year 1, year 2. This is day 730. So there's 365 days a year. 365 times 2 is 730. So you already have, some data for the first 2 years on demand, what the demand looks like, and you expect the pattern to continue. And then you need to manage the factory for the next 2 years. Okay, so the simulation ends on day 1460. That's year 4, end of year 4. Okay, so years 3 and 4, this is where you are going to manage the factory. So they've already shown you what happens in the first 2 years, so you have a baseline and you can project demand forward. And then you are going to make decisions and try to make as much money as you can for the next 2 years. At the end of 2 years, you can assume the product will go obsolete, so there's no value of ending inventory. So you don't want to end with a huge amount of inventory, which means often teams will make some adjustments to their order point, okay, and perhaps order quantity as well at the very end, because you don't want to end the simulation where a huge order is just arriving at your warehouse from the factory, and then that you've spent money to get the order to manufacture that, and then you're not going to sell it because there's no sales after the end of the year 4, the second year you are in control. Okay, and so the ending you can try to optimize that, but that's a minor point. Even if you don't try to optimize the ending, you just run it as a continuous operation and you do a good job, you should end up making decent chunk of money and making some profit. Okay, so let me put from the write-up the numbers which are important in the Excel file. Okay, so I went through the PDF and this is the information I found. So on the market or consumer side, the price they pay for a drum is $14.50 per drum. Notice I put units in front of every term. There's some demand. I have to find the average and standard deviation or somehow describe the demand. I look at the last 2 years of data to do that because, as I mentioned, the factory's been running for 2 years. And at the beginning of year 3, I get control of the factory and I'm going to control it for 2 years, year 3 and 4. These demand is fulfilled by the warehouse. So warehouse to customer costs us $150 to ship a drum from the warehouse to the end customer. The storage cost for a drum is $1 per drum per year is $100, plus there's a financing cost of 10%. That's going to be applied to the landed cost of the drum at the warehouse. At the factory, this is given at the end of the write-up as their cost of financing. So 10% year on their cash. So to spend that money on inventory, you're losing the 10%. So that'll be part of the holding cost at the warehouse. The capacity at the factory is 20. So notice I'm going through the supply chain this way. So starting from the end customer, going back. But that's just convention. You can do however you want. So at factory, I have a capacity which is 20. Cost to increase the capacity by 1 drum per day. This is 20 drums per day. This is daily capacity. You can see the units here. So to make it go from 20 to 21, I'll have to spend $50,000, and also takes 90 days for expansion. So if you expand the factory, the capacity will not change right away. It'll take 90 days to take into effect. When you place an order at the factory from the warehouse, because warehouse is the one that orders the factory, and you can, insert an arrow here if you want to represent that the order will go from here to here, right? Okay, so that order, you have a fixed ordering cost of $1,500 to place that order. And then you also have to spend $1,000 per drum, pay the factory that much. And then you're not done because you have to pay for transportation. So factory to warehouse, if you transport by mail, you pay $150 per drum. It takes 1 day. If you transport by truck, it costs $15,000 per truck and it takes 7 days. And a truck is going to hold 200 drums of capacity. Shipments happen when the order is complete. Okay, so even let's say you placed an order for 250 drums, you have produced 200 drums. The 200 will not get shipped in one truck. When the complete order of 250 is complete, then you'll use 2 trucks. One will be full, one will be mostly empty to ship the order when the order has finished production. So that's the most of the numerical data given in the write-up. Okay, then we also have data in the simulation. Okay, so let's look at the simulation. Here you want to look at the most importantly the demand data. Okay, so this is this scenario is complete. So this is 4 years of data. But when you start the simulation, you'll be on day 730. You'll have 2 years of data at the start. You can see that the pattern stays relatively the same. There's a lot of randomness in demand too, up and down, but the pattern stays the same. So let's actually download this data. Okay, and I am going to copy the 730 days of data that we start with into my analysis Excel file that I'm producing. So I go down to day 730. Okay, and this is the data I have when I start the simulation or in my planning phase when I have access to the simulation in a paused state. Okay. Okay, and this is my data from the case write-up, from the simulation write-up. Okay, so let's kind of look at this demand, plot it, analyze it, and kind of try to understand it. We can also obviously, calculate the mean and standard deviation of this demand for the first 2 years. We can use the equals average function and select the first 2 years of data. So we can see that over the first 2 years, our average demand is about 39.19 drums per day. Okay, this will be per day. And you can think of it as approximately 40. And then we can also find the standard deviation.s, stdev.s, because you have a sample of demand. Let's calculate that. Shift control, and you press the down arrow and it selects all of those cells for you, and you can hit enter, and that is our standard deviation of demand. So you can see that the standard deviation is more than half of the average value. So that's a lot of standard deviation. That's like quite variable demand. Okay, so let's start by just doing a plot of the demand. So I'm just gonna select this column, insert, do like a plot. Should I just do this? Yeah, the circle's gonna make it look a little bit ugly. Let's just do this. Okay, so that's what our demand looks like. I do want to change this color into something lighter. So let's see if we can do that. Okay, so if I right click this and I go to color, I can change it and I want like a gray color. So that's my demand. And you can see it's very noisy. It's kind of hard to see the peak. Well, it's about maybe on average 80, but it's going up to above 120. So one thing you can do is you can smooth the demand. So you can do a moving average. Let's start like a 9-point average. So you go 1, 2, 3. Let me zoom in a little bit here. So you go today, days 1 to 9, you can calculate the average of the first 9 days, and you'll put it at the middle of this window, which is day 5. So the day 5 will get an average of 4 days before day 5, and 4 days ahead, so 9 days total. Okay, and then you can drag it down like this, and you'll see it's a moving average, right? So this window slides along. Okay. And let's take it all the way down. And then obviously at the very end, okay, you can't do the last 4 days. So this, for example, is fine. But on these last 4 days, you can see that it's going out of bounds. And so this is fine. So these 4 you need to delete. Okay. Okay. So now we'll take cell C2. Okay, down to C731 and plot it here. So we go here, right click, select data, and then we add a line. This is series name is this. It's the 9-point moving average, and I go from C2 to C731. Okay, so let me just select here. What am I doing wrong? I don't understand. Let's just select it like this. And I want to select the empty cells as well, so that I know that in the beginning and end I have 4 empty spaces because of my moving average. Okay, let's scroll up. So there you can see the moving average is a lot smoother, and I'm going to give it a bright color so you can see it clearly over the actual month. So that's your moving average, right? It's easier to see the peak. The peak is around 80 once you do some averaging to make it smoother. You could go more. You could do like a 13-point average. It has to be an odd number, right? So then you'll take the first 13 days. The middle day is day 7. Day 7 will get the average of the first 13 days. Okay, and then you just drag the formula down. And then because you are going 6 days above and below the current day, you'll have to delete the last 6 days. Okay, and we can add that here too. Select data, add, that's going to be called MA13, and we select this values all the way down here. Okay, and let's see what that shows. Oh, did I select the wrong column? Oh, I averaged the wrong column. Okay, so my apologies. This needs to move here. Demand, not the day. And go down. Okay, this is perfect. Getting the last window till the end. And now let's make this a little bit brighter. So light blue. Okay, so you can see how the smoother demand looks like, right? So this is good. So we know that in the off season, our demand has a low of about 10, and in the peak season, it has a peak of about 80. And if you look at your standard deviation, it's about 27. It does seem to 80 plus 27 would be 107. So it does go up. It does go some days about 2 standard deviations above the mean. Okay, but that's rare. Most of the time, it's within 1 standard deviation of the mean. Okay, and if you want to see that, okay, let's do this. Let's take MA9 plus P for plus 27. So I'm going to add 27 to these values to look at the mean plus one standard deviation, because I know my standard deviation is about 27 from my calculation, right? Okay, and then I can drag it down. Okay, and delete this and this. And we can plot this line to show you that that should go somewhere like here. It should capture most of the demand underneath it. Okay, so let's go to select data, add, gonna be MA9 plus, I'm gonna call it standard deviation, SD, plus SD. Okay, and for this one, I select this column. Okay. And here this, let's make it nice bright red. Okay, so you can see that, you know, demand is most of the time below one standard deviation and the mean, right? It also falls to one standard deviation below the mean, but there are a few spikes which go up to 2 standard deviations plus the mean. But if you are able to meet the average demand, you still have some lost sales because demand is, you know, about half the time above the mean. But if you're able to handle a demand of mean plus one standard deviation, you will be able to capture most of the demand. And, you know, any demand lost, you lose out that sale, you lose profit from the sale. Any demand that you capture, obviously you make the sales. But obviously you have some excess capacity. Look at the white areas where there's no demand. Like your capacity, if your capacity or core capacity plus inventory, whatever you're using to meet the demand, is designed for the red line, there are places where you have extra capacity or so on, or inventory. You know, that's a decision we have to make. How are we going to manage our capacity and inventory? Okay, and we're going to talk about that. So right now our capacity is 20, which is really low because very short amount of time in the year, right? So this is about 1 year, right? 365 about here. Okay. We are below 20 for like a month on each end. Just 2 months out of 12, our demand is below 20. Most of the year, demand is above 20. So 20 is not enough capacity for sure. Okay. So we can calculate, you know, the amount of demand which exceeds capacity, so let's call it excess demand, with the current capacity of 20. So whenever this number is above 20, we want to calculate the difference between that number and 20. So we'll take the minimum of 0 and 20 and demand minus the capacity of 20. So when demand is lower, 20, the capacity, now we're going to take 20, yeah, the demand minus capacity. So when the number is above 20, you get a positive number, which is the excess demand, but sometimes you get a negative number. And if you do get a negative number, that means you have enough capacity, so you're fine. So we don't want the negative number, so that's why we do a min of 0. Sorry, a max here. A max of 0 and demand minus 20. So whenever your demand is less than 20, you'll get zeros. And whenever demand exceeds 20, you'll get how much the demand is above 20. So look at that. When demand went to 31, it exceeds demand by capacity by 11 because capacity is 20. So you get the excess demand here. Okay. So you can drag this all the way down. Okay, and you can see that most of the area of positive numbers, you have excess demand. Okay. Okay, so let's see what we are going to do with our capacity. So let me move this out of the way. Let's calculate the sum of the excess demand. So over 2 years, let's calculate the sum of the demand. Okay, and I just want to calculate a percentage. So this divided by this. So you can see that's about 56%, 57%. 57% of the demand is excess demand. It's above our capacity. And if we don't do something about it, you'll be losing all that demand. So that's pretty sad. What if we set our capacity, instead of 20, we set our capacity equal to the average demand, about 39 or 40. So let's calculate what will be our excess demand when our capacity is 40. And I don't want to make it into a link. So at 40 capacity. Okay. So there'll be max of 0 times demand minus 40. Okay. And you'll see that, you know, it doesn't lose any demand. There's no excess demand even when the demand starts to pick up, because now our capacity is a lot more reasonable, and only in the peak months do we get excess capacity. Okay. So this was excess demand at capacity of 20. Okay. Let's move this down. Let's do excess demand at capacity of 40. So that'll be the sum of this column. Okay. And you can see that's a much smaller number. And now you're only missing 27% of the demand. So really capacity of 20 is really looks like to be too small. We're starting at extreme capacity constraint. And so probably we need to increase the capacity. So now let's talk about how are we supposed to fulfill this demand. So let's draw the general shape of our demand. So over a 2-year period, it looks something like this, as we saw in our Excel plot. The peak is at 80 on average, you know, and as I showed you, that it does go up by about 27 more. So it's like 80 plus 27, about 107. Because it goes, usually, or quite often, it goes 1 standard deviation above the average. So the red line is the average. This is 1 standard deviation above to 107, right? So if the peak is 80, I'm saying that's the on average, and it will go 1 standard deviation above and below, right? And sometimes in rare cases also 2 standard deviations above. So the average is 80 here. The average is 10, okay? And the midpoint of 80, this right here is 40, which is our average demand. Now, what happens at the midpoint when you have this seasonal demand is that this area is your, well, if our capacity is 40, then we can easily handle this demand below 40. So this, in the area under the humps, this represents your excess demand that you can't handle with your capacity of 40. Okay, this and this. Now notice that currently your capacity is 20. So you have a lot of excess demand. 57% of the demand is excess demand currently. Okay. So there's multiple ways to fix it. Well, one way is to increase the capacity to the average, which is the 40, the midpoint. Okay. And what that does is when you increase the capacity to the midpoint, until this day, let's call it D1, you have extra capacity. So you can produce more than you need and save it as inventory. Okay. So this will be called excess production. You can do it if you want to. You can produce more than the demand, excess production. And you can save it as what we call anticipation inventory. Anticipation inventory is inventory you save in anticipation of a peak in demand or a high season of demand. And then here, again, you can have excess production. Okay. And you can save it up for the next peak. And here you also have excess production, but you don't want to save it up because you end after the second year of your management, which is year 4. But at day 1460, you end operation. So there's not a lot of point in this extra production for you to save it as anticipation inventory because you have an end date for your factory. So we're going to ignore that one. So I'm going to erase that. Or maybe just label it as don't need this one because your factory is going to end, like your simulation is going to end. Okay. Okay, so if you're at 40, your excess production is going to be approximately equal to the excess demand. Okay. So your excess production will approximately be equal to your excess demand. How do I know that? Because I set my capacity to the average, and I know by definition of an average, half the time you spend above the average, half the time you spend below the average. Average tends to be in the middle, right? So if my capacity is in the middle, then if I run it constantly at a capacity of 40 drums per day, I never have an idle day, I'll produce excess capacity here, and these green areas will approximately equal the black areas of excess demand. And you can check that in your Excel calculation. So we have excess demand at capacity of 40. Okay. I somehow managed to make that a link, so I'm gonna fix that. Okay. So this is your, so let's look at your excess production at capacity of 40. So here you're gonna produce 40 every day, but you're gonna ship out the demand and keep anything remaining. So if demand is 11, you're gonna ship out the 11 and you're gonna save the 40 minus 11 as your excess production. Okay. But if demand is more than 40 and you get a negative number, you want it to be 0. So min 0 and then 40 minus that, because when you get to big numbers, you don't want to say your excess production is negative or you don't have any excess production. Okay. Sorry, I didn't need to do, I need to do max. I need to take out the negative numbers. It has to be max, not min. Apologies. So max. So here I have excess production of 29. Okay. And then when demand picks up, you can see my excess production goes to 0. And it peaks and it's always 0 because demand is so high. I'm producing 40. I'm sending 40 to meet the demand and still not meeting the demand. Okay. So let me sum up the excess production and see how much it is. Okay, so excess production at capacity of 40 will be sum of this column. Okay, which is 8391, which is larger than your excess demand at capacity of 49. At capacity of 40. Why? Because your actual average demand is 39, not 40. If I make this number 39, you'll see they'll match more closely. Okay. See, they match much more closely now. 7800, 79, 96. Because I am, setting my capacity close to the average demand. So I'm going to keep it at 40, just because nice round number. Okay. So here I have excess production of about 500, 600 units, which is fine because my demand it's kind of like you can have a little bit of safety stock because you don't know if demand is going to follow exactly the same pattern next year, right? So this would work. This is one strategy. You could set your capacity to 40, but then you have to make sure that you run the factory at 40 throughout. You never let the factory stop producing because you need to get this excess production out and saved as inventory in the warehouse, okay? To meet the peak season demand. Okay. Let's look at year one, which is up to day 365. Okay, if we go to which is cell 366. So if I just do the first year, okay, so that's gonna be 366 for 1 year, and I do this for 1 year. You notice that they match pretty closely here as well. Okay. So this would work, okay, for the first year as well. Okay, so what's another strategy I can do? Another strategy I can do is, okay, that's not a very good diagram. Let me draw again. Okay, so this is 80. Okay, my average is 40. And I noticed that if I keep my capacity to 40, I have to run the factory throughout the year to have enough excess production to meet the peaks. But you could say, well, I'm going to set my capacity to the peak, to 80. Set capacity equals 80. And then you don't need to do excess production. You have what we call, you're not capacity constrained anymore. Your capacity, your demand is, for the most part, always less than capacity. There's some going to be peaks where you miss some of the demand. So you may want to carry some safety stock, right? But the average of the demand, the smoothed demand, is going to be less than the capacity or equal to. And so your capacity will go up and down, like your production will go up and down to match the demand. So here what will happen is production can follow the demand. So if you you can basically set your order point, increase it to if your capacity is 80, you can just set your order point and order quantity and forget about it, because as your demand grows, you'll hit the reorder point more often, and you'll keep placing reorders with the factory to get extra inventory, and the factory will be able to produce the extra inventory in time because its capacity is high enough. Okay, so your production can just follow the demand. If you go with the blue strategy, you set capacity to 40, then must have continuous production because you want excess production to generate anticipation inventory for you. Okay. And now this is a little bit tricky part, so I want you to pay attention now. How do you tell your factory, I am following the blue strategy, produce continuously, and how do you tell the factory, I'm following the green strategy, produce as needed, because your maximum capacity can meet like the maximum demand? Because your factory here has no option, okay? Your factory here has no option about these strategies. There's no button to flip here to set the strategy, okay? So the way you do that is using your reorder point. In the green strategy, when you can chase the demand, your production will chase the demand because your capacity is sufficient for the peak demand. You will set the order point like a traditional reorder point from the QR inventory policy, reorder point policy, EOQ model. You've done that in your inventory calculations or in operations management courses. So you can just set the reorder point. This works when your capacity is sufficient and the demand is not going to go above your capacity. For continuous production, what you do is you set your order point to some really high number, like, I don't know, like 2 million, okay, or more than the total demand for the year. So that means your inventory in the warehouse will always be below the order point, and you'll always keep the factory running. You'll say, oh, I need to go up to 2 million in inventory, which you're never going to get to, right? Because even if you run at 40 units per day, for 40 days, even if you produce 40 units per day times 730 days, 2 years, you're only going to produce 29,000. So you're never going to, and some of that is being shipped out to the customers. Your inventory is never going to hit like 1 million or even like, 10,000 or 20,000. So you can set the reorder point to some massive number like 30,000, 40,000, 100,000, and your inventory will never reach that point. It's just a very high number, and that high number will just keep your factory running continuously. And so that is the trick we can use in the blue strategy. Okay, set the order point right here. I said this right here. I said the order point something massive like 20,000, 30,000, 50,000, 100,000, some massive number. And because you're never going to be able to reach that inventory level, the warehouse will keep ordering from the factory one after the other and keep the factory running continuously. Okay. So you either have to run the factory continuously with the capacity of 40, or you can set the capacity of 80, or you can do an in-between strategy. You can be in the middle and you can set your capacity something like 60 or 70 or 50, right, as you wish. And then for those cases, you'll know, okay, my peak is when, which day? Well, it's about the middle of the year or something, right? You can look at the Excel file, and you can see the peak happens around day 190, right? So you can calculate how many days before this is day, let's say 190. So you can calculate, when does your demand cross over this point. So if some days before that, maybe 30 days before that, you'll switch to continuous production. You'll store up some extra. You'll do excess production and increase your inventory levels. So when your capacity does go above 60, this anticipation inventory you've built up in the warehouse will supply that demand, right? So you can figure out, you can look at the last year's demand, see exactly at what point does demand cross 60, and then, okay, how much excess demand do you have if your capacity is 60? You have to produce that much. So to produce that much, when do you start going into continuous production mode? And then when demand falls below 60 again, you come back to like the normal mode, and then somewhere here you again go into continuous production mode and produce anticipation inventory. I like the red and the blue strategy, the strategy of setting capacity to 80 or 40, because in both of them you don't have to go in at certain times to change your factory's production. At 80, just set the reorder point and you can just relax, and the factory runs as it needs to. It kind of changes the demand. Or with a capacity of 40, you just set it to continuous production at a very high reorder point, and then again you can relax. But if you set a in-between capacity of 60 or 70 or 50, then you have to switch to continuous production mode to build anticipation inventory for certain days. Then you have to go back to reorder point mode, like chase the demand. When the demand falls below 60 or 70, then you have to go back to anticipation, building the anticipation inventory, continuous production mode. So you have to switch between these two modes at different points in the simulation. So if you can do that, you can be on top of your game. That's fine too. But these are the strategies you have available to you, right? So you can do continuous production at the average capacity equals average demand. You can chase the demand at capacity set equal to the peak demand, or you can set something in between and switch between the chase the demand mode, which is the standard reorder point mode, or continuous production mode, which is building anticipation inventory, right? So you can do that. So we have talked about one of the most important decisions, which is what capacity to set your factory at. At this point, you can do a break-even analysis, because going from a capacity of 20 to 40 means increase capacity by 20 drums per day. Okay, and that's going to cost you, that has a cost. We saw $50,000 times the increase required. That's how much money you'll have to spend. $1 million to get this capacity increase to go from 20 to 40. And the point is, what's the benefit? Well, will this increase in capacity pay back for itself? Well, I know that the excess demand at capacity of 20 was this much. I was losing sales of about this much. A little bit less than this much because you could produce a little bit of anticipation inventory, but close to that number. And if you go to capacity of 40, you will not be losing these sales because you will, your capacity will be able to handle a lot of them, and then your excess production, but running that capacity, the 40 capacity, running at 40 throughout, will build this much anticipation inventory. This is how much anticipation inventory you can build up with your excess production, and that can handle that as well. So you potentially will be able to sell 16,000 more drums. So the benefit is you can potentially sell about 16,000 more drums, okay, over 2 years by spending the $1 million. So does selling 16,000 more drums give you a profit which is at least 1 million? That's your cost benefit analysis, right? And so we can calculate that by looking at how much profit do we make, okay, by selling a drum. And we have all the cost data here to do that calculation. So we want to calculate how much money we make by selling a drum, right? So there's the price. And the money we make is going to be different whether we ship it using mail or if you use it a truck. So we have to calculate the profit two ways. So this is, let's do truck and then mail in these columns. So the price is going to be the same for both. Actually, let me just do equals and pick the number from here. Equals this number. That's also going to equal that number. Okay. And we can first calculate, take out the production cost. Okay. So production cost, that is the variable production cost of 1,000. That's going to be the same here as well. Okay. Now we have the transportation cost, which is different for the two. For the mail, it's just 150, but for the truck, it's 15,000 per truck, but there's a capacity of 200. And so what if we figure out if we were to ship full truckloads, okay? So if we were to ship a full truckload, it'll be about $75 per drum. Now that's assuming we full ship truckloads. That will depend on our order quantity. So we have to make sure our order quantity is multiples of 200, because otherwise our transportation expense will be a lot more. Like you don't want to ship 250, that's using 2 trucks, so $30,000, right? So let's say you ship 300. So $30,000 is 2 trucks. If you divide that by 300 drums, that's $100 per drum, right? And so you don't want to do that. So you want to ship 200 or 400, right? So you still $700 a drum. So we can say this is going to be 75, okay? Then you have to ship from the warehouse to the customer for $150. So that's ship to customer cost. Okay. Then there's going to be the inventory cost. For a certain amount of time, the drum is going to be on the way 7 days or 1 day from the factory to the warehouse, and our money is invested in that. So there's what we call a pipeline inventory cost. Okay. And how do we calculate that? Well, first we have to calculate what does it cost to have a drum in our system for 1 year. Okay. So when a drum arrives, when a drum leaves the factory, we've spent $1,000 on the drum, so that's the value. Okay. And so $1,000 times the financing cost of 10% gives you $100 per year, right? So let me just do like a rough calculation somewhere here. So financing cost of a drum is going to be the 10% times this. Okay, that's before it hits the factory. Okay, the warehouse, before it hits the warehouse. Because at the warehouse, then you have to pay for the truck, and then you have to increase the landed cost by the transportation cost, right? So if you go back to our inventory cost lecture, we covered the landed cost and all of that issues and pipeline inventory cost calculations. Okay, and then it also costs to store in the warehouse for about $100. Okay. But we have not done that. So during the pipeline inventory from the factory to the warehouse, we are only paying for the money invested in the drum, which is $100 per year. And a year has 365 days, so divided by 365, that's going to be about 0.27 something dollars per day, right? So this is going to be 10% times 1,000. That's for a whole year. Then you multiply that by the number of days you're in the pipeline over 365. You're in the pipeline for 7 days. Okay, and for the male, it's going to be the same. Okay, calculation, except you are going to change the 7 day to 1 day rather than 1 day. Okay, so this is a tiny cost, but that's your pipeline inventory cost. And then if you ship it straight to the customer, that's it. Let's say it doesn't spend any time in the warehouse, but if it does spend time in the warehouse, then you'll have a holding cost as well. So let's first assume it doesn't really spend time in it. It's received from the factory and the same day goes out to the customer. So then my profit, okay, will be my price minus sum of all the costs. Okay. And so you can see that you make $223 on a drum if you're using the truck method, and if you use mail, you're making about $150 on the drum. Now, some drums will spend time in the warehouse because you'll be building anticipation inventory, and those drums will make less money, right? And so we have to factor that in as well. So let's say a drum spends time in the warehouse. So let's calculate the inventory holding cost, okay, for a drum that sits in the warehouse. So that is going to be $100 per drum, which we are given. Right here, storage costs for a year. So this is per year for now. Then we do 10% times the landed cost, which is going to be the 1,000 plus the transportation cost to the warehouse. Okay, and so that will be the inventory holding cost for a drum for 1 year. So that's per drum per year in the warehouse. That's inventory holding cost in the warehouse. Okay. Okay. Now let me put the dollar signs here and here, and not on the 75 because I'm going to drag it to the right. And for the male, it's going to be more because the landed cost is higher. You spend more money to get it to the warehouse. So that's $215. Okay. So that's your inventory holding cost on the drum per year. Now, how long does a drum spend as anticipation inventory. If we go back to our plot, okay, if your capacity is 40 right here, you're building anticipation inventory till day 71, or actually maybe day 85, and then you're going to start using it up, and you might use it up, you know, over this time period. So you can just say, okay, if you on average till day 80, the average is 40 till day 80. So from 40, if you go to the average here, about 200, so about 160 or 150 days, about 5 months, you know, 5 to 6 months, about half a year, or 5 months, or 4 to 5 months, your drum will spend as anticipation inventory if your strategy is to have a capacity of 40. If your strategy is to have a capacity of 80, then you'll not be building anticipation inventory, maybe a little bit of safety stock, and then the average drum will spend much less time in the warehouse. Okay, so, you know, just to kind of eyeball it, let's say a drum spends 5 months in inventory. And that's not all the drums though, because, you know, when the demand is above 40, the capacity of 40, in those months, you'll be shipping drums that arrive from the factory as well as shipping some from the inventory. So those drums produced in that time do not spend that time in the inventory. So not all drums will be spending these 5 months in the inventory. Okay. And so let's so if you do spend 5 months in the inventory, that's going to be 5 over 12 times the cost to hold a drum for a year in inventory. So the 5 months, that cost will be about $86. But not every drum gets this $86, right? And so you can look at, okay, with a capacity of 40, right, your production, your excess production will be spending time in inventory, but not the rest. If the demand is 16,000, if 8,000 of that you're meeting with excess production, then half the demand you're meeting from your capacity, which makes sense, right? Because your capacity is the average demand. So half of the demand, and so let's just make it 6 months. Okay, so half of the demand we are fulfilling from our production immediately, and the other half we meet from our inventory. Okay, so about half of the drums produced will end up in inventory, where they'll spend 4, 5, or 6 months. So half of that will be 0.5 times that. Okay, so maybe you can add, on average, you can subtract $51 from your profit. Okay. And for the case of male, maybe $53. Because when a drum is in inventory, it spends like 6 months there, but you don't, you know, when you're in the peak season, when your demand is above 40, then you're not adding drums to the inventory, you're eating up your inventory, right? So your inventory levels, if you want to draw them, right, your inventory levels would go up, then decrease, then go up, then decrease, right? They'll go up as long as demand is below 40, and then this is the point where demand exceeds 40, and then you eat up your inventory, right? And then this is, and as long as demand stays above 40, here demand is now below 40 again. So you start building your inventory again, right? So that's how your inventory graph will look like. And so whatever that inventory level is, you'll have half of that inventory. So we know that the total inventory over the year is going to be about 8,000. Okay, so we have 16,000 demand. About 8,000 we fulfill from inventory. The other we fill from production. So you can divide 8,000 you can find the average inventory level by doing some more calculations, but you don't have to. You can just say that, okay, 8,000 pieces is what you're gonna build up your excess production into inventory and supply the demand here, and which is half the demand. So half of the production will spend time in the warehouse, and they'll not spend a whole year. So 6 months is a good guesstimation of that. So half of your production spends about 6 months in inventory. So on average, a drum, if a drum did spend 6 months, it will cost $103. But since half the drums, you have the $103, half the drums have 0. So on average, you do half of 103, which is 51. So your profit can be estimated as this minus the expected inventory holding cost for a drum. Okay. And so that's how much money you'll be making under the strategy that you run the factory throughout at a capacity of 40. So $100 or $170. So we can then see that if we are spending $1 million and we make $170 of profit, so my break-even quantity will be my investment amount divided by my profit per unit. And so if I'm able to sell 5,800 drums extra, I will pay back for the investment in capacity with trucks. And my break-even quantity, if I use mail, is going to be the $1 million divided by the profit per unit using mail. So that's going to be about 10,000. Okay. Now, we do realize that my demand is 28,600, sorry, not 16,000. My demand is 28,600. Okay. 16,000 was the excess demand if my production was set to 20. So my demand is 28,600. Okay. I was losing 16,000 of that. So by spending $1 million, I'm going to meet all of the 16,000 demand. So the extra demand I'm going to be able to meet is a lot more than 5,000 or 10,000. Whether I use mail or truck, this is the demand I was missing out on. I will be able to meet this demand by excess production or whatever strategy I follow. And so spending $1 million to go up to a capacity of 40 is totally warranted. In this case, it's above the break-even quantity, my extra demand that I'll be able to meet. Okay. So just to recap, because it's a little bit confusing. Okay. Capacity is 20. You can go up to 40 by spending $1 million. Okay. This $1 million pay back for itself if you sell about 6,000 units using truck and about 10,000 units using mail. Okay. But when you go to capacity from 20 to 40, you're going to make extra sales of 16,000 units because that was the lost demand previously. And because this extra quantity sold is way more than the break-even quantity, you're going to make profit from this decision. So it is profitable to put in $1 million into capacity expansion because the extra sales you'll make is going to be more than the break-even quantity. Okay. Okay, now let's talk about, so that's one major part of the simulation. The second major part of the simulation is this order point and order quantity. Okay. So let's do that. So we can try to use the EOQ formula to figure out the order quantity. Okay, this is all the assumptions of the EOQ formula are not being met in this setup that we have. Okay, but we know that the EOQ formula, the total cost curve is pretty flat. So as long as you're approximately right, you're gonna get most of the savings. So it's not a big issue. So let's take the data that we need to do the EOQ calculation. So you need the setup cost, and we saw that at the factory, the fixed order cost is $1,500 per order, right? S is always dollars per order. So this is that $1,500 cost here, okay? Our demand, we calculated that our total demand, it's a very important number, for 2 years is this number. But you can't use this number in EOQ because EOQ wants annual demand. So you have to divide that by 2 to get the annual demand. So you can take this number, that's over 2 years. So divide by 2, and that's your annual demand. Now your holding cost, we calculated here, was the $100 plus the 10% of the landed cost. So it's 207.5 or 215 depending on what you use. So if you use truck, it's going to be this number. And if you use mail, it's going to be this number, 215, right? So this is also an important parameter. Let's make it blue and bold. Okay. Then the EOQ formula is, let me just write it here for you. It is EOQ equals 2ds over capital H square root. This is the annual demand, D. This is the fixed order cost. This is a holding cost per unit per year. This is not a percentage. If you have a percentage, you have to convert it to per unit per year by multiplying by the landed cost of the unit, right? And so we already have H. So EOQ for the truck case, so actually let me move it down and here put truck and here put mail. The EOQ will be square root of 2 times annual demand times S divided by H. Okay, and for mail, it will be square root of 2 times demand times S divided by this H for mail. Okay, so 454, 446. But remember that our truck capacity is 200. Okay, so we have to ship multiples of 200. So for a truck, I would set it to 400. Because 454 is closer to 400 and 600 because you have to be either 400 or 600, and 450 is closer to 400 and 600. You don't want to be 450, that's going to use 3 trucks. So you might as well be 600 if you're going to use 3 trucks, or you might just do 2 trucks. So that I can round down to 400. For the mail, I can just set it to 447 because the mail does not use trucks. It's going to be per drum, you get a cost of 1. Whatever the cost to ship by mail was, 150, right? So there's no batch size. You can just ship 1 drum. Whereas for a truck, you have to have batches of 200. Okay, so this is how I would set the order quantity parameter. Okay, how much to order between the warehouse and the factory. Now remember, because I said that we're not meeting all the assumptions of the EOQ, so this is not exactly perhaps optimal, but it's close enough. It's good enough. Okay, and then our question remains our last parameter, which is order. This is quantity. So order quantity here, you would put in 400 if you're using trucks. If you're using mail, you can put 450, 447, 400, 500, anything approximating 450, 446 is going to be correct. Okay. And so for order point, it depends on what strategy you are following. If you are setting a capacity of 40, you want to do continuous production. So you're going to set to something very high, like 50,000 or something, right? So that you're continuously running the factory. Okay. But if you are following a strategy of capacity at 80, then you can do the regular reorder point stuff. So reorder point. So reorder point equals, reorder point formula is ROP is demand per day times lead time plus the safety stock right? And safety stock is Z times SDL, standard deviation of demand during lead time. So all those formulas are given to you in the inventory cost calculation type of lectures, right? And so you could do that here. So you have to find the lead time. Now, if you are using, if your capacity is 40, is 80, and you're ordering 400 units as order quantity, then the factory will take 400 divided by 80, that many days, 5 days to produce your order. Your capacity is 80, right? After capacity goes up to 80. And then to this one, you want to add the transportation time of 7 days by truck. So lead time is going to be 12 if you're going truck. This is for capacity at 80 and for a truck. Okay. And if you're using mail, it takes 1 day. So it'll be 4. And if you're placing order, let's round it to 450. So if you're placing an order of size 450 divided by 80, it'll take you 5.6 days to produce the order. Plus, you'll spend 1 day on the mail. The mail is faster, takes 1 day. So it'll take you, lead time will be 6.625 days. Okay. And then your Z will just be norm.s.inv. You want to set 95% availability level, 0.95, or 90% cycle service level, whatever your cycle service level is. Okay, if your cycle service level is 95%, then this will be the Z to use. Okay, which comes from norm.s.inv of 0.95. Okay. Now we know the standard deviation of demand per day was this one. And because lead time is fixed at 12 days, my SDL, standard deviation of demand during lead time, SDL, will be the standard deviation of demand multiplied by square root of the lead time. And I'm going to put dollar signs here. Right, so, this should